My name is Uwe Maaß. I'm with Fraunhofer IZM in Berlin, Germany. So Fraunhofer is basically involved in the design and the manufacturing of the integration platform. So this means like developing the processes for building the hardware demonstrator, and also doing research actually into processes and designs for building front ends for the 5G application. And in particular, we're doing the design of the demonstrator that is being done in the end, so of the module, and this includes design of components like antennas, which will go into the module, and as well as the electrical design of the package. So the main achievements in the Serena project in the first half of the project were basically development of the process technology for building the hardware demonstrator. So this were quite challenging from a technical point of view, because it was new type of chips that were never been used before in embedding processes at IZM, also new materials that have not been used. And also in adapting the technology to the application, so to the high millimeter wave applications, the high frequencies, and to put all this together in a design so that it works from an electrical point of view, but can also be manufactured in the end. So the challenges actually were also related to this embedding process. So as mentioned, we had new types of chips that have never been used before. So there was a new necessity to build new, or to make a new technology to actually contact the chips. And then also in the design, as mentioned, the process itself was never applied to high frequency or to millimeter wave applications. And we had to characterize the technology to understand the electrical behavior, and then design the technology in such a way that it works at the millimeter wave frequency. So for the work package we are involved in, which is more related to the hardware integration, we would be trying to build up test structures to actually validate that the process and the manufacturing process that was developed can be applied to build such a demonstrator with several ICs, and then can also be used in the demonstration scenario in the end. And therefore we will build several simpler test structures to show that this is working. So there we will gain some knowledge on the design again, also on the manufacturability, and this will help us to build a reliable demonstrator in the end. So for the whole consortium, I think so the development, of course, should go on, but we should focus on the demonstration in the end, so that we can show the possibilities we have in the technology, and then show that the module that is being built and all the aspects that are worked on in the different work packages are actually work together to build this new type of front-end module. So that's a difficult question. So for us, the development would stop at the prototyping phase. So as soon as we have demonstrated that the technology itself is usable for these kind of applications, I think there will be like a stop for the project at least. So I could imagine that there are other companies who are interested in the technology, especially those companies who are already using embedding processes for building modules for other applications, for example, power applications, who also want to test this for their own products. But I would expect that the time to market will still take a couple of years if we have like really the Serena module in focus here.